All right, cool. Let's get started on this. So, welcome to the Introduction to 3D Printing, part of the Libertarian Party of Georgia Technology Workshop series. So, in this today, we're going to go through some of the basics, broad overview of 3D printing in general, some other kinds of sort of home decentralized manufacturing, as I like to call it, um, and how to get started in this. So, if we have time, we'll try to do a little bit of a demonstration. I've got the printer set up behind me, so we'll see if it wants to cooperate today. So, um, if there's nothing else, let's go ahead and get started. Um, yeah, first thing we want to do is thank our sponsor here. That is Osprey Shooting Solutions in Rome, Georgia. OspreyShootingSolutions.com. Edgar there is a professional instructor, knows his way around firearms, and can teach like none other. I went out there when LP Georgia had an event with him, learned a lot from him, and I can't recommend him enough. Complete professional. Safety's number one out there. No one's going to get hurt, and it's a good time. You learn a lot. So I highly, highly recommend checking out Osprey Shooting Solutions for some firearms training. Who am I? Uh, my name is Nick Soselsky. I am currently the vice chair of the Libertarian Party of Georgia and chair of the Libertarian Party of Fulton County. I have a Bachelor of Science in Mechanical Engineering from Carnegie Mellon University. I've got about 8 years of engineering experience designing railroad products for a large part of that, briefly flight simulators and flow control valves. So I'm in this space, designing, manufacturing. That's what I do. So the 3D printing kind of fits right in with what I do professionally, and that's how I ended up here. So, decentralized manufacturing. So I kind of define this as types of manufacturing that make parts that would previously be impossible to make with easily accessible equipment at home, right? So things that are computer controlled, 3D printers fall into this, CNC equipment like routers, laser engravers, mills, and lathes, becoming more and more consumer friendly, more and more available at home. Previously, you're talking massive, 20, 30, 40, 100 plus $1,000 for some of this equipment. Massive, just completely impractical for the average consumer to have at home. There's a lot of companies out there doing a whole lot of different things, bringing the price down in this. 3D printers, real cheap, $100, $200. $200 gets you half decent hobbyist consumer grade, all the way up to, you can get some better ones in the $800,000-$900,000 range. So it's a fairly uh, easy thing to get started with some of these things. So let's talk a little bit about 3D printing in general. You're not going to do a lot of this at home, but there's a whole lot of things that can be done there, right? So the large thing that people are always looking at with 3D printing, polymers. That's always the large one. That's what you're generally going to be doing at home. PLA is kind of the king of home 3D printing. It's easy. We'll get into a little bit more there, but ABS, PETG, thermoplastic, elastomers, TPE, those kind of four there are your kind of consumer grade at home things, at home materials. There are systems that'll print concrete that they're trying to print houses out of, print bridges, all sorts of stuff. And then as you move up into some of the crazier stuff, you get into printing ceramics, these specialty engineered ceramics, or even just a more simple clay. And then metals. Metal printing is taking off more and more and becoming more and more cost effective. I think I've seen desktop systems going at about $50,000 to print metals, which comparatively has come down in price significantly. So all depends what you're trying to do, but you can print steels, titaniums, certain steels, titanium, stainless, copper, nickel, super alloys like Inconel, aluminum, chrome, cobalt, chrome alloys, things like that. And then you get into composites as well. So your nylons with carbon fiber, ABSs with Kevlar, PEEK, these kind of like high-end composites that are used largely aerospace, but a whole lot of other things. So whole wide range of what this is being used on. Like I said, though, our kind of bread and butter here is going to be these four here: PLA, ABS, PETG, and TPE. That's kind of what you're generally going to see at home. So let's talk a little bit about the different kinds of 3D printing, because there's multiple different ways that this happens, right? So your most basic way here, this is what I have behind me. This is what you're going to pick up for $200, $300, up to $1,000, somewhere around there. This is generally what you're going to have. It's called a fused deposition modeling FDM printer. So this is by far the most common form, especially at the hobbyist level. You're going to print from a roll of filament here. It's going to feed down, push through, and the head of the printer is going to build it up layer by layer. It melts it, and it's just going to lay little lines down. You're going to have motors. You can see here you have a motor mounted acrossways. That is your X direction, your Y direction, and your up and down is your Z direction. And you can get fairly large with this. And the design is simple enough and firmware open source enough that you can modify and build these as large as you really want to. I mean, the limit is, whatever you really want to get at and as practical. Usually it's going to be somewhere around 200 by 200 millimeters by, I don't know, 240 tall, I think is about the general size of the one I have behind me. But if you really wanted to, you could figure out how to make these several feet large and whatever you wanted to do there. The next type that we're looking at are the resin printers. So this is a little bit different of a technology, but basically it comes down to two different things. We have DLP, digital light processing, where it's going to kind of expose a layer of this resin to light in a particular shape, and that's going to build up that layer. Then the next layer is, so as you see, it's upside down in the picture here, because it's going to raise layer by layer out of the bottom. I don't have one of these. I haven't really played with it. Stereolithography, SLA, is actually the oldest technique for this, and it cures this resin with a laser versus curing it with a light. The materials aren't as standard as FDM. They're, kind of held secret by the companies that make it. What you're going to see here is largely, at least at the hobbyist level, you're going to be weaker with these materials. They're not as structural, but they do have a higher resolution for higher details, like you see here, for like making little models. And often these printers are a lot smaller than the FDM printers. So powder bed fusion. This is getting into the industrial side, but how things kind of works on that. So what you get here is basically a layer of metal or polymer powder, whatever you're using on this, whatever the printer's made to print, will lay across the entire bed, and then you're going to have a laser or other energy source, electron beam, however the machine works, is going to basically print the pattern out on that layer. A new layer of powder is going to get laid down on top. The laser is going to run over it again, and it's going to build that up layer by layer out of the metal or polymer powder. Certain types of this can be used for both polymers, thermoplastics, and thermosets and metals. Binder jetting, kind of similar, but rather than melting, it's applying a binder layer after layer. So some sort of adhesive that's going to hold everything together and build it up layer by layer. Adhesive, whatever bonding material it is. I know I don't really know all that much about this. I have never used anything like this or the previous one, the powder bed fusion, but I wanted to cover that it's out there. Um, it exists. People, these are kind of what can be done industrially. So, maybe at some point we're going to see some of these get to the consumer level, possibly. So let's talk about some of the basic fuse deposition modeling FDM materials that you're going to see. It's good to kind of know some of the basics. So the first one, PLA, polylactic acid. Like I said, this is the most basic filament you're going to find. You can get these from all over the place. There's a million different manufacturers, a million different places to get them. They're easy to come by. They're easy to print. Fairly low temperature print. They've got some decent strength to them, especially on their higher end, the higher ends of their range. You'll see that some branded as like PLA plus, where it's kind of formulated for a little bit of additional strength. Being an engineer, we look at yield and ultimate strength. So if you look at this curve here, and I put this here just as a reference to kind of look at it, but we're looking at the stress versus the strain here. The stress, how much force per square inch, and then the strain, how much is it stretching. So along this line, you see it kind of is kind of like if you think of a spring and you're pulling a spring along this line, this part of the line is where it returns to normal. Once you get past this, you pass the yield strength. That's where, like, when you're pulling on the string, it doesn't shrink back down and it stays stretched out. So most materials will act like a spring, and this is kind of how we measure and classify them. And it'll go from the yield, and it'll slowly start stretching, plastically deforming up until the point it breaks. So that's kind of how we're going to look at strength on these materials and keep going along. ABS. This is a more not consumer, but a more slightly more difficult material to print. It has a tendency to warp and also needs ventilation when you're printing because of the fumes and gases. So I've never actually printed it. It goes a little higher in temperature, but it's stronger, and ABS is used in a whole lot of different products around from the commercial products. So it's it's definitely a stronger material, but you're going to have to deal with shrinking and warpage and things like that to print it. So it's a little bit more of a challenge. PETG. So this is also fairly simple one to print. I've printed it before. I've had decent luck with it. It's, I'd say, a little bit stronger than ABS, but also PETG kind of is technically falls into a food safe plastic, so it could be used for additional for some additional additional things that you wouldn't want to use like a PLA for. Although I'm not convinced on ever really using this 3D printed plastic for anything food related, but PETG is a food grade plastic, so that's something to keep in mind there. And then thermoplastic elastomers. Never printed these, but what they are closer to kind of rubber They're still a thermoplastic, but they stretch more. They print at a low temperature, low bed temperature. Not very strong, but if you wanted to make something up that's flexible, there's a whole range of thermoplastic elastomers. This falls into a very wide category. So, you might get into some issues with these because when you're running this filament, usually you've got to push the filament through a tube that's about a foot long or so. And so, being flexible, it might get caught up in there, might be a little bit difficult to get loaded in there. Um, but, you know, it offers properties that other ones don't. So this is where we kind of get into something stuff that's interesting. Nylon. So this is a more difficult one to print. It takes higher temperatures, higher bed temperatures, but now you're getting into like real consumer level products, things with some actual strength that you might want to use if you're building, depending on what you're building or want to print. So these nylon filaments can get expensive, especially when you're talking about fiberglass reinforced nylon or carbon fiber reinforced nylon. They are more expensive, but like I said, absolutely a much stronger product. Polycarbonate, never really mess with this either, but as you see, it's a higher temperature but also higher strength. Apparently not that difficult to print. I've never messed with it. And then PEEK, which is out there, this is more of a aerospace grade filament, and you're probably going to have a difficult time hitting 375 to 410 degrees Celsius on your printer and holding and maintaining 130 to 145 C on the print bed. I mean, those are some high temperatures. Keep in mind that water boils at 100 degrees C. So, I mean, you're trying to keep that bed really, above the boiling point of water there. So that's going to be difficult, if not impossible, but you might be able to get away with it if you wanted to spend, 100, 200, $800 for a kilo of this filament and mess with it. If you were feeling interested in that. And then the last one I wanted to bring attention to, PVA, polyvinyl alcohol. So this is not really something that you'd use to make a real print. I mean, you could, but really its properties, its positives come from the fact that it dissolves in water. So one of the best uses for this would be to be running two extruders, two ends on your printer. And oftentimes, if you have overhangs or you might need some internal supports on something that you want to be hollow, rather than cleaning it out, it would make sense to run this filament as a support material. And your PLA or PETG or something else like that as your body. And then upon finishing the printing, run it under water. This would dissolve and you'd be left with the finalized print. So interesting properties there. Could be really useful, really helpful on a lot of different things. I know I've done some prints that have been done with a support material like this, like whole assemblies. And then you wash away this and you're kind of left with everything already assembled and you kind of have your motion. It's, I did that a long time ago in my first job, but yeah. So that kind of brings us to the end of our the main materials I want to talk about. Now, let's talk about some of the general hobbyist printers. There's really two names that stand out to me in this. Well, I guess three, but two. So the two really that I'm thinking of are Creality and Prusa. So these three are Crealities. This would be an Ender 3, and a newer version of the Ender 3 than what I have, but an Ender 3, which is an open source, very basic, very simple 3D printer, highly upgradable, a lot of aftermarket parts. We have up here, I think that's a larger I can't remember if that's an Ender 5 or another Creality printer, but this top one is a larger, kind of bulkier printer, just an upgraded version. They'd be very similar, very, probably better controls up here. This Creality one, their CR30. This is interesting because it's they call it sort of an infinite Z. And if you see, the print head is on an angle here. So it's printing and it's moving down the bed, allowing you to get massive, prints as long as you want and as long as you can make it continue going. So that's a very interesting kind of printer that not too many other places have. I haven't seen too many other places, but is available. And then you have Prusa, which is another consumer, very close to the Ender, probably going to run you a little bit more money. And then I guess also there's like MakerBots and things like that. That's kind of the names you're going to be seeing. But really, I think Creality and Prusa kind of have the home market. There's other off brands and a whole lot of other stuff you're going to see that looks very similar. I mean, these are all very similar parts. If you look, these are standard aluminum extrusions you can buy, cut to length. You can buy boards like to find the supplies and build one of these is not the most is not the craziest or most difficult thing you're going to do. So all right, getting files to print. All right, now that you have, all right, so if you've got a printer, we want to, we want things to print. So we're going to have a couple different ways to do that. The easiest ways are going to be going to a place like Thingiverse or GrabCAD, even McMaster-Carr, which is an industrial supplier, but they have 3D models on there, so it's incredibly useful for getting some of these off-the-shelf parts, bolts, nuts, things like that you might need if you were to be making your own models for printing. But let me pull this up here. So if you were to go to Thingiverse here, let me give me 1 second here. See if this works. It doesn't like me logging in. It gets like that sometimes. Yeah, so if you look here on the thingiverse.com website, you're going to see all kinds of projects people have made and created, everything from this portable laptop stand, Uno card shoe, knife sharpener, mini belt sander, USB cord, anything you can think of, modular hydroponic grow tower with grow lights. You're going to find a whole bunch of really anything. You can come in here and just browse and browse and browse. People upload it. If you could sign in, which for some reason it's not signing me in right now, you can download basically anything for free. It'll ask you if you want a tip, but oftentimes, they're going to give you all the models that you need, all the mesh files you would need to set up the print, as well as a lot of people create videos and give further instructions, especially for something like this, which is going to be running with a motor, on how to hook that electrical up safely. Or something like this, a hydroponic grow tower where you might need additional parts that aren't that might not be 3D printed, or something simple like this vase here, which would just be a purely 3D printed object. So you'd be able to hit download here. It's going to let me download. It did let me download. So I'm going to extract that for later, and we'll take a look at it a little bit later on. But that's Thingiverse. You're going to find some other websites like GrabCAD, McMaster. Like I said, McMaster-Carr. There's a whole bunch of websites. That's kind of the big one. The next way you're going to get parts is make them yourselves, right? So there's multiple different ways to do this. The there's some open source options, FreeCAD, although I haven't used it. I've looked into it a little bit, and I guess certain things about it can be kind of buggy. Or Blender, which is a more robust, like 3D sculpting tool, I guess. So I'm not sure if it would work in the same ways, but I know people will use that to make those figures and more, more complex sort of artistic pieces versus, usable, sort of like practical pieces, I guess. Although I'm sure Blender could be used for both. So if we're talking computer-aided design, we have a couple options here, sort of basically professional level software with hobby licenses. Let me show you one here that I didn't include because it's kind of a way to mess around. It's called Tinkercad. It is by Autodesk, which company makes AutoCAD, Inventor. They make a whole bunch of different design software, everything, anything designing buildings, designing products, is a lot of it's done on Autodesk software. So this is a reputable company, but it's a very simple way. Apparently, I didn't learn this, but people I do know who aren't versed in 3D modeling have said, "Oh, this is a very easy way to do it. That you can kind of just drag shapes, set dimensions, set lengths, widths, heights, and create parts just like that." So that's something that you can get a free account for and mess around with, called tinkercad.com. Additionally, there's companies like PTC and their Onshape product, which is browser based, so nothing you install on your computer. It's limited on a hobbyist license, but it does have a free option. Additionally, software like Fusion 360 like this, it has a personal hobbyist license. So you can download that. It's limited to 10 active files, and a whole bunch of other things are locked down. But your basic modeling and assembling is there. And then probably my favorite, because it is a complete package here, SolidWorks 3D experience. Costs about $100 a year, and it's a full SolidWorks professional license with some cloud-based stuff and some other stuff. And if you're looking to get into it, that's at least my way to go, because that's, SolidWorks I've used professionally. Fusion 360, I haven't come across anyone using that professionally. So I would, those are things to look at and see what you think there. So moving on to setting up the 3D printer, because we really need it. That's what you really want to have there, is a good setup, and have it set up right in order to get the best print you possibly can. So The first step, often they don't come assembled, especially these cheaper ones, the enders, things like that. So you're gonna have to assemble it. It's all pretty simple. Basically, you've got, you're gonna attach some of these bases together with screws, attach these vertical pieces, the top piece, and then this carriage here. You've got your power supply, a screen, you've got your bed, and that's largely what it is. I mean, there's instructions, there's videos on YouTube, things like that that'll really walk you through step by step, depending on which printer and which model you might purchase. It's a, this is a very simple process. Now gets into the tedious part. The first thing you want to do is level the bed. So you want to, you want a level bed so that your print doesn't come out sideways, so that it lays down properly. Um, so what you're going to see on the bottom of the beds are four wheels, one in each corner, and you're going to tighten these to lower it, or loosen them to raise the bed. And you're going to want to make sure that your stop for your extruder head is set right, so that you can properly raise and lower this, so that it's not too high or too low where you're running into this head, or the head's not getting low enough. On the printer, there's going to be an option to turn off the stepper motors, so that you're not so that the steppers are disengaged, so that they're no longer providing any force or resistance whenever you go to move this. And you're basically going to move the nozzle to each corner of the bed and turn this wheel and slide either a piece of paper or a feeler gauge. A piece of paper is probably the easier way. Most people don't have really thin feeler gauges, but basically you want to slide a piece of paper between the print surface and the nozzle until you feel just the slightest bit of resistance. Like, you don't want the paper pushing the nozzle up at all. You just want it to very slightly touch, and that's about the proper height. You're going to do that to all four corners. Once you do it to all four corners, you're going to check it again and keep checking it over and over as you adjust everything to make sure that that bed's completely level. Following that, you want to take steps to calibrate it. This is going to depend on your printer, exactly what you want to do. Make sure you're tightened up and that the printer's not loose in any way. The first thing you want to do is check your extrusion and make sure that your extruder is extruding the right amount of material. So you'll measure, you'll mark it with like a marker, measure 100 millimeters from a point on the extruder, and then kind of just run that all the way, run at 100 millimeters. You heat, you turn on the preheat, and then you're able to manually on the printer adjust that and tell it to run 100 millimeters, and then you'll be able to measure and see how far off it is, and then do some calculations based off of the certain printer. And all that stuff is easily available online, and enter that into the controls to adjust that. And then very similarly, there's things like this calibration cube here, which are going to print in your X, your Y, and your Z. And you're going to want to run one of these, and then once you're complete, measure it, make sure that sizing is correct. I think these are usually like 10 millimeter by 10 by 10. Make sure that you've got the right size there. And if not, then adjust each one and check it and make sure that all of your axes are proper. And then you should be good from there. You can then do some more crazier tests. Like, there's these calibration cats here that have some complex features in there, right? So anytime you have to overhang space like this tail here, or on this benchy boat, which is going from small and widening out as it goes up, as well as this large overhang on the front. You have to be very precise and take very small steps in order to get those to build up over the air like that without supports. So this is kind of a test to see if your printer is set up enough to handle that. So, those are fun ways to get started and make sure that you've got the printer set up right. So, getting ready to print. Now that the printer's set up, now we start to work towards getting the printer, getting the file set up and ready to go. So, if you're running this if you're coming out of a CAD's program like Fusion 360 or something like that, or SolidWorks, we're going to save the CAD file as a mesh. So this is going to often be .stl is the most common. Fusion 360 is also doing a .3mf, which includes some additional data in it, but STL's kind of been the standard. And if you're downloading from, say, Thingiverse, usually you're getting the STL file. You're not usually getting a SolidWorks model or a step file, which is a generic CAD model. Usually it's the mesh. So so you would be able to skip this step, but if you're modeling it yourself, we'll go with that. Setting up the print, we're going to drop, the product. We're going to drop it into the slicing software. The model can be scaled, copied, repositioned, whatever you want to do. You can do multiple parts. You can do multiple copies of the same part. Rotate it, put it however you want in there, scale it up, scale it down, whatever you want to do. You set it up in there, and then you're going to make selections as far as what material it is. Oftentimes you go in, you're going to set up materials in there based off of like the temperatures I told you for the particular material. So PLA, you could go back and look and see what the recommended temperatures for the bed and the filament extruder are. You can set that up and then select it. There's going to be additional options as far as infill. If it's a solid part like this cube here, you're probably not going to want to run just purely solid 100% infill. You would want to maybe do like a 10 or 20% infill. And so there's going to be patterns to infill it. That selection, it's going to figure out for itself, depending on what you tell it, how to fill in inside of that cube where you're not going to see it. And then once we have all the selections there set up, we hit slice, and it's going to generate G code. And the G code is going to tell the printer what to do. So at that point, we can take the code, put it on a micro SD card, or USB stick, whatever the printer takes, place it into the slot. Some upgraded boards or screens, like I have an upgraded screen that has an SD card slot on the back of the screen, and a USB slot on the screen, on the back of the screen. So those are usable places that I can plug into, and I'll be able to then pull up the code, pull up the program on the printer. And then there's software and external servers, basically. So these are often run on like Raspberry Pis. I've run one before. That's kind of where my setup is, although I don't have the server set up right now. The big one here is Octoprint. I come to like a lot of the features on Repeater. And what this allows is you have the server, it's set up on your home network. I use the software on this side as the slicer, and then I can then upload that to the server, and then I'm free to release it. I can upload a bunch of different files to the server. and then hop on my computer, my phone, my tablet, whatever's on the home network, and able to hit release whenever I want to release a particular part, and it'll start on the printer. So that makes things easier rather than having to carry a USB stick or a micro SD card back and forth. Preparing the print materials. So a lot of the materials, if they're coming straight out of the box, straight out of the packaging, will be fine and ready to print. Certain things, PLAs, nylons, a lot of the other filament will just naturally absorb water in the air and become brittle. So they're not going to print as well. They might snap. So what you want to do is you want a dehydrator or a dryer box. I believe some people have even like set ovens on low heat and kind of like on a really low heat and with the door open, kind of just put those in there and let those sit there for a while and just heated that the water out of it so that the filament is ready to print. I have a heater box behind me on my setup. I don't know if you can see it right there, but it just sets at a certain temperature. There's no fans. It's just a little bit of heat applied to it. And then over the course of a couple hours, you can tell, especially if you have a little bit hanging outside of it, there's a big difference between it inside and it outside. So once that's set up, we start the print. The first thing to do, and something that people don't always think about initially, is we want to have some sort of adhesive on the print bed surface, on the print surface. A lot of people use a glue stick for this. I've had a lot of good results using hairspray on a glass print surface. So I have a piece of glass sitting on top of the metal heated bed and held with 4 clips, and I'll spray that piece of glass with hairspray before each print, and I've never had an issue with it pulling up. Oftentimes you have to wait for it to actually cool down enough to kind of pull away from the pull up and kind of start shrinking just a tiny bit so that you can get the part off, especially if it's a thinner part. That way it doesn't break. I've had it where if it's still warm and you try to pry a thin part off, a thin flat part, it'll bend and warp as you do that. So oftentimes, once the print's done, you want to sit back and wait a little bit, wait for the bed to cool down. That way you can get the part off without damaging it. And then from that point, you're going to use the control software, tell it what file to print, and go with it from there. And the printer should take care of the rest if everything's been set up properly. Now, like I mentioned, a lot of the printers are open source. The Crealities are. There's a lot of upgrades. I've upgraded mine. I'm going to show some of the ones that you can buy. There's a whole lot more, and there's even more upgrades that you can print. But if you're getting into this, there's ones that are definitely something I'd recommend. Upgraded control boards. If you're getting like a base model of the Ender 3, like I had, it will be loud. You're gonna hear a burp, 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 burp every time every time the stepper motors move. It'll get annoying. It'll drive you crazy. An upgraded board, which is basically plug and play, pull the old one out, drop a new one in, basically hook everything up to the same place it was. There's instructions and videos on how to figure that out depending on the particular board. But having an upgraded board with more optimized stepper drivers brought the noise down massively. It's at the point now that the loudest part on my printer is the fan you might hear, and I actually have a 3D printed muffler on that as well to bring the bring it down a little bit. So bring the noise down on that a little bit. So all kinds of things you can do as far as that. But these upgraded boards will often have, additional features, more accessory ports that you could hook up to, better heat sinks so that you can run longer without burning it up. So, and they're not usually that expensive, maybe 40, 50 bucks. So if you buy a cheap one, it's a good way to step it up. Screens. I also have an upgraded screen on mine. I have a touch screen. It's basically this one down here in the bottom. It has additional slots on it for USB, SD cards, and it offers a little bit more control than the standard screen that you get with it, especially being in color. You can see things a little bit more, get a little bit more feedback. You don't have to be scrolling through the menus with the little wheel that you turn and click and turn and click. It makes for a much easier, nicer experience. Auto levelers. So I have one of these, but haven't gotten around to getting it installed. Oftentimes, You need to print your own bracket to mount it, but these will measure the relationship of the bed to the tip of the of your printer. That way, and then it'll kind of create it'll then kind of instruct the software on how to compensate for the shape of the bed. If it's sloped one way, or it's high in the middle and gets lower on the sides, it'll pick up and allow the software to determine how to optimally print without you having to fight through the piece of paper and adjusting those wheels constantly. So that's another very common thing that you see people installing and upgrading on. Hot ends. So this is the part that actually heats up the filament, and your print nozzle is attached to the bottom of it. A very common upgrade with these is what's called an all metal. Your standard ones have like a plastic lining, and that's going to limit how hot you can get. Going all metal allows you to get up to like the nylon temperatures. You're not going to get up to nylon beyond with a standard hot end. There's additional ones that have the extruder built in, so you don't have to, so that it's just pulling all the filament and putting it right in. It's not pushing it. It's not pulling it while pushing it down the tube on the printer. And there's other ones where you can have two extruder motors running two different filaments into one end, and have complex mixing controls. Basically, tell it how much of which color to print, or which material to print, or some combination. I've seen some YouTube videos on these. They can get some pretty interesting combinations and do some nice interesting things. I'm not exactly sure how practical they are, but they do offer a solution like that if you can't get a second extruder set up on your printer and you wanted to run two different materials or two different colors at once. It could allow for certain setups to purge out one color and then push the other color through, so that you can run two separate colors, or like I said, mix it so you get a combination of the two colors. Transition from one gradient across the gradients between the two colors. It's really very much open to what you want to do. The next one is nozzles. So generally, you're going to use a brass nozzle. That's the standard. It's going to work for PLA, PLA, PETG, ABS. Oftentimes, brass is all you need. If you wanted to get into the nylons, especially when you're talking about fiberglass or carbon fiber, mixtures of nylon, which those filaments themselves, you're going to talk, I think I mentioned it on the peak, but those ones, probably 100 or $150 a kilogram for those. So they are not cheap to print. And so you don't want to be wasting that. But the glass fibers and the carbon fiber are going to wear away these brass tips immediately. So in order to do that, it's recommended at least with a hardened steel. But I've also seen a ruby tip recommended, or diamond if you're really trying to prevent the carbon fiber from wearing it away. As far as other kind of similar equipment that we have at at home, I've mentioned it before. You know, these all kind of fall into the same sort of thing. 3D printers build it up. These kind of take away material. So a CNC router, it's kind of a two, two axis cutting system. So another way that you can manufacture things at home depending on your needs. I see those priced on Amazon starting around like $200. CNC laser engraver cutter. So all these, if you look, it's all very common extrusions like the 3D printer. All the motors are all very common. The controls are all very much similar. Just kind of the number of axes and the tool on the end are it's really all that's different there. But a laser capable of cutting wood and some other materials. That's priced around $200 plus again. And then CNC mills, you can see here is Defense Distributed's Ghost Gunner, which I believe starts around $3,000, but allows a lot more, the ability to cut aluminum, mill aluminum, and make all sorts of complex shapes that you're not going to get with those other ones. So especially something that's focused on a metal like aluminum like this. I don't believe it does steel. That I think is going to take a much larger, more robust system. But there's like some CNC machines like Tormach that I think people will purchase if they have the money and are inclined to. That I think start around like 10 grand. So that's kind of the range you're looking with those. It'll be nice to see CNC mills start coming down in price, especially desktop things for the for something like aluminum, because that offers a whole new world of things you can make if you have the ability to mill or turn if a desktop lathe happens as well. So that's kind of our CNC, kind of other tools that kind of fall into the same sort of home manufacturing category to look into that use very, very similar control systems. Practical applications. So we could kind of see even looking at the Thingiverse, the hydroponic hydroponic thing that was shown on there. Let me pull that back up. The modular hydroponic garden, right? You can print things for simple things at home. Even a knife sharpener, belt sander. There's all sorts of little practical uses. One of the most interesting applications I have found are in the firearms. There's a whole industry going on as far as the firearms. Know the laws in your area, what's legal, what's not. There's all kinds of stuff that are both legal and illegal to make and print. Just running through some of these pictures. This pistol is a single shot with the cartridge and the barrel built into this little adjustable, a little insertable piece there, and you can slide it in, fire off the round, throw another one in. So that's kind of an all plastic pistol frame. You've got your standard pistol frames that you can print out, buy off the shelf parts, assemble plastic AK-47 receivers. You can buy barrels and stocks, attach those. Things that are illegal, like say a Glock switch or a lightning link for your AR-15. Like I said, those completely illegal. Don't print those. And then you have the FGC-9. So this was sort of the first fully home manufactured firearm. All of the external components are 3D printable. The only thing that isn't really 3D printed or right off the shelf is the barrel, which is in the technical package that you could download on it, would tell you what kind of pipe to buy for that, and also some techniques that they developed on how to rifle it. So this is really interesting on how they came up with rifling barrels and building barrels and assembling these things. So I see a lot of innovation in the field, in sort of the 3D printing field, coming out of this on how to make things practical out of this plastic. So a lot of groups, Defense Distributed is sort of the first company. That's Cody Wilson's group. They do the Ghost Gunner. One of the biggest helps as far as like getting set up on 3D printing, controlpew.com. He's got a guide on getting started. Whenever I started setting up my own 3D printer, I kind of followed that step by step. So a lot of good info just on there. Catalog. So this is sort of their website where they store all the files you could ever want to look at as far as 3D printed firearms. And the last one, not so much 3D printed, but they are doing some interesting stuff with the idea of it being home manufactured, and that's Atlas Arms. They're working on homemade ammunition, especially what they're calling more or less armor-piercing hollow points that don't meet the definition of armor piercing. So that they would be legal to manufacture and possess at home. So I know they've made some progress on it. I don't know as far where they are as far as having a package to download and look at, but there's a whole lot of innovation in this space, and I think it's some of the most practical applications I've seen. Especially being the Libertarian Party of Georgia, we're always looking at what's going to create more freedom, and these here, the ability to say, hey, we can print whatever, you can ban it, but we can print it and we can have access to it, and there's nothing you can do to stop us. These FGC-9s, I have seen pictures of those showing up in the Civil War or at least in the fighting that might be in Myanmar against the whatever government coup that went on there. So people were starting in these war zones that don't have access to weapons are starting to get weapons to defend themselves and be able to make their own. So I think this is some of the most interesting technology out there for that, and something that should be looked into. So that's all I've got as far as presentation. If you guys want, we've been going for an hour, but I'd be happy to do like a quick demo as far as like running from like a very basic part to getting it set up on the printer. It just might be a little bit difficult because I've only got the webcam running. So this is Fusion 360. You can get it for free off of the Autodesk website, a personal license, Google Fusion 360 personal license, hobbyist license. The full license, I think, runs about $500 a year. I didn't want to pay that much for this. So, basic starting point, we can create a sketch, select where we want the sketch to go. You can you've got shapes up here. So I can select a rectangle, set it at the center here, click the dimension button, set this to, say, 2 inches, 2 inches, jump over to the solid, hit extrude, and let's call it 4 inches. So we've got a basic little rectangular part. So in this infusion here, to create it over to create a mesh, I'm going to click the part. I'm going to hit save as mesh. I'm going to get this option. It's got the file selected. I'm going to choose STL, unit type inch, and then refinement high. And I'm going to hit OK. And we'll just save that to downloads. So, if you wanted to learn Fusion 360 Autodesk has some really nice tutorials getting into a lot of detail on this on YouTube for free. Very easy to check out, walk through step by step. I highly recommend that. So next thing you would do, hop over to your slicing software. This is the Repetier Host, which is uses a slicer. It has the actual slicing is done with whatever slicer you want. Prusa slicer, Slice 3R slicer, or Cura Engine. Those are all, I think slicer is about the most common. It's just integrated into this, which is nice. So I can hop over to my downloads folder, and that part that we just made, I'm just going to drag out of the folder and drop it right in here. So I have in the software initially set up the printer, the print bed surface here, as well as the height to get this full volume. If I wanted to copy an object, I can select an object. I can set, 5 copies of it here, 6 copies of it here. If I wanted to run it all at once, or one, I can recenter it. I can rotate it however I want. Whatever I think makes the most sense depending on the part. You can, all sorts of controls here. Scale it if I think I could scale it. I can scale one dimension of it, or I can scale all dimensions of it at once so that it stays with the same ratio. It kind of, it gives you all sorts of additional control in here, especially if you're downloading just a mesh and you might want to bump up the size or bump down the size. This is the right place to do that. Fusion 360 offers a little bit of mesh, a little bit of ability to manipulate mesh and convert it to a model, but that's a little bit more advanced and a little bit limited based on the software. But basically, we say we're going to use slicer. Let's see, I have this green filament set up in here. Print setting default, printer settings default, enable cooling, we don't need support. Layer height, I want to do, that's 0.1 millimeters. That's fine. Infill density with something like this, I would probably want it around 20%. If you took it all the way to 100, that means it's going to be a solid block of plastic. You could take it down to 20 would probably be about right. And you have options for infill patterns, rectilinear, honeycomb. That would all be up to you to kind of figure out how you wanted to do things and, experiment, see what works best. If you're doing something that's supposed to hold actual weight and take something up versus be sort of decorative, You're probably going to want to print it at 100% infill. Certain things I've seen spec, especially with like ABS, that you want to infill it with, at like 105% so that it overfills, so that when it shrinks, you're back to the size you want. So once everything's set up, and I'll show you kind of what we're looking at as far as the configurations. Um, yeah, so you'd have to, you can come in here in the slicer settings, and you'd have to come in here and set up the print controllers. So your layers, so your layer height, first layer height, infill patterns. You set up sort of all of your basics in here, and then filament, your diameter, extrusion, your temperatures for this, density, and even you can throw the cost in there. As if you get everything accurate, you're going to be able to kind of estimate the amount of time it takes to print. And if you know the time and the amount of filament, you can also estimate cost. So it gives you a good ability to kind of understand what you're dealing with, how much money it's going to take. So if you were to, maybe you want to do something on the side and print some parts for friends or something, you know what your cost and your time is going to be. But once you're set up, we're going to hit slice with slicer. It's going to run the slice, and it's going to come up with, it's telling me it's going to take 11 hours to print this. And I don't often believe this. I don't think it's really set up, but you can see it's kind of, if you zoom in, it's kind of set with the layers. It's kind of calculated what it's going to look like, which layers need done, so that it knows. And then basically what we're going to do is hit save to file. And I'm going to go ahead and plug in a USB drive. And I can save that right to the USB drive. And at that point, we're ready to print. So I can pull this out. Let me see if I can adjust this camera a little bit and see what I can do here. Okay, so I've got the 3D printer set up, and I don't know if I can get the screen, but now that it's plugged in, we turn it on with the control on the side here. And basically what we're going to do is go to print. I have it on a USB, so USB disk. And then I'll be able to select that on here. And I could tell it to print. I would first need to load my filament that I have here, coming off the top out of the dryer box into the extruder through the motor back here. And then, like I said, hit this with hairspray so that it adheres to the bed. But after that, everything should work fairly well as far as printing that part. And everything on that is kind of a, just a variation of doing that. Um, so that's kind of the basics there. Last thing I'll just show is I have I've mentioned there's a whole bunch of different, you can print your own upgrades for the printers. I have cable management and things like that all built onto my printer. And I've been working, like I said, to get a server, a Repetier server on a Raspberry Pi built. And my big project on that has been actually trying to get my own custom designed casing that wraps around the back and hides in the back with with this part sticking out the side, which would actually have a 2 switches in it. One switch to power the Raspberry Pi on and off and give me my own power switch for that I don't have to go reaching for, and the other one would be to power the power a light I want to put inside of the stand. And I wanted to run both of those off of the power on my power source on the printer. Step it down from the 24-volt power source on the printer to the 5 volts to run a light in the Raspberry Pi. So there's all sorts of very fun little projects you can do. A lot of the time you're going to find yourself just experimenting and printing stuff for your own printer. So that's kind of all I've got here. I'll open the floor for some brief questions if anyone's got any. Nothing? No, I see Ryan says if anyone's looking to get a printer to play around with, you can pick up a Creality Ender 3 Pro at Micro Center for $100 if you sign up as a new customer. I would jump on that offer if I were you. That's a good price. I highly recommend the Ender 3, especially the Pro. I bought the Ender 3, just the standard one, whenever I bought it. I think that was $200 a couple years ago, and that required me to get another board to keep the steppers quiet. I believe the Pro's already got some of that built in, so your steppers aren't quite as loud. So yeah, if you don't have a printer, $100 is a pretty easy investment to get one and just start playing with.